Okay, 8.5. We're just looking at two different types of lines, so mid segments and medians. So a median is going to be in a triangle like this. You're going to be connecting a midpoint, so splitting that in half, to a vertex. So triangles can have three different medians where they split these in half. And then one nice thing to know is that these lines, so like, let me use a different color. Like this line right here, let's say this is A, B, and C. So these have a 2-to-1 ratio for that line now. So that means that AB, okay, AB looks longer because it is longer. It's 2 times BC. If you were trying to get BC and then the whole line AC, oops, not BC again, AC. If you notice, if this is 1 and this is 2, together they make 3 times that are initial length. So if you have the short piece and all the way across, it's a 3-to-1 ratio. Okay, so 3 times the short piece. If you have the long piece and the short piece, it's a 2-to-1 ratio. And then the last thing is if you have the long piece, so let's say we had AB, and then you also have the all the way across piece, so this is all the way across, then AB is going to be 2/3 of BC. I think I did that wrong. Yeah. I said it right, wrote it wrong. Okay, 2/3 is of that all piece all the way across will give you the long piece. Okay, so like if this was, just for example, if this was 6, okay, that would mean this is 3. And the whole way across would be 9. That's a gross picture, but let me show you a little bit sketched out down here instead. Okay, and those should all meet. So this is saying that this length right here is 3. This length right here is 6. And then the length all the way across is 9. That's that 2-to-1 and 3-to-1 ratio. Okay, so this was 3 times the length, and this to this was 2 times the length. So I didn't put an example problem up on here, but your homework has a few of them. So that's why I want to make sure you know that relationship. The other word we have is mid-segment. So a mid-segment takes a triangle, and then you're going to be connecting, instead of midpoint to corner, you're touching midpoint to midpoint. So those are equal and those are equal, and you create a line there. And we're not going to draw all of them at the same time, but there are 3 different ones you could have. And then this relationship is a 2-to-1 ratio, which means that if this is 5, this is 10. You're just doubling it. So looking at this problem, HM is from here to here, and NM is from here to here. And if you notice, we know that these medians that go from midpoint to corner make 2 equal sides. So HM, if this was like X, let's see, X, then this would be X. So that means there's 2 of HM in every long line NM. So we don't know that, so that's X. But we do know NM is 4.5. And we just get X alone. That's it. And in this case, X was HM. Okay. The next problem has a median, a mid-segment, yeah. So mid-segment goes from midpoint to midpoint, so we know that these are congruent sides. And we also know that this times 2 equals this. So short times 2 equals the long side. Even though it might look like there's less x's, it still works out. So we distribute that, and we get 4x minus 44 equals x minus 8. And then we're going to move the x's to one side and the numbers to the opposite side. So we get 3x here, and we get 36 over here. Divide by 3, and we get x equals 12. And if it asks you to plug it back in, like if they wanted xv, you would say, okay, 12 minus 8 equals 4. That's only if they asked you. And that is it.